This is a quick demonstration of SolidWorks Plastics' capabilities to help designers check the manufacturability of their plastic parts. It helps to predict major defects such as short shots, air traps, weld lines, sink marks and much more, way before they actually appear on the part and then require mold redesign. So let's take a look at the interface. As you can see on the screen, this is the part we have designed and that we would like to check for manufacturability using SolidWorks Plastics. After enabling the add-ins, you have a new tab and a new ribbon. Then you can apply a quick mesh of the geometry and then send the processing condition. First, the polymer selection, about 5,000 materials in the default database. We're going to choose a polycarbonate to manufacture this part. Then the injection machine. The goal is to make sure that the machine you are going to use is powerful enough to fill the mold, so you can try default settings. Then some process settings like the filling time and mold and plastic temperatures, and then the gate location. You can set more than one gate, there is no limitation. We're going to choose the gate in the middle of the part and then validate. So it just takes a few seconds. We can run the calculation. We're going to skip on that very quickly and then check the results. As you can see on the solver window, there is an error message. A short shot has occurred, which means that with the current conditions, the mold is not going to fill. If you look at this merefront animation, you can see some gray areas, and this is where the mold doesn't fill. So your part cannot be manufactured with the current conditions. So let's take a look at the part design. If we use the section planes from SolidWorks, as you can notice on the screen, the part was large and slim. So we can switch back to the design tab of SolidWorks, edit the shell function, and change the thickness from 0.05 to 0.1 inches. Then we can switch back to the SolidWorks Plastics tab, remesh the geometry quickly, and then look at the results. And as you can see, when we change the thickness, just increasing the thickness a little bit, the part can fill properly. So the part is now manufacturable. We have been able to avoid this problem before building the tool. Now that we have found the right design for the part, we can build a mold layout. So using SolidWorks, you can duplicate your part. So let's try a 4-cavity layout. You can also design the runners using sketch lines from SolidWorks and also 3D sketches. Then we can switch back to the SolidWorks Plastics tab and very quickly build the channels using the sketch lines, assigning section types. It could be square, circle, trapezoidal sections, assigning the dimensions. So it's going to be the diameters. So we're going to use 2.5 millimeters for the runners and for the gate from 2.5 to 1 millimeter. We can now validate our channels. The last thing to set is the gate location. So very quickly you just select the top of the sprue here and then validate. We can now run the analysis. So again, we're going to skip the calculation time, and as you can see, there is the same error message, the mold doesn't fill. So let's take a look at the results. And if we zoom on just one cavity, you can see that the forefront is stopped right at the beginning of the fill. So let's try to change the runner diameters. So let's go back to channel design. So we're gonna do that quickly. We just changed the runner diameter to 5 millimeters instead of 2.5 millimeters. And then apply, run the analysis, and if you look at the results, the 4-cavity layout fills properly. So now let's try another layout. As you can see on the screen, the part is actually in two parts with different volumes. So we can build a family layout of the mold. So we have two cavities with different volumes. We can design the sketch lines to make the runners. So let's go to channel design and very quickly build the runners. So we apply the same diameters for both cavities and then run the analysis. And as you can see on the screen, if we have a look at the forefront animation, the part on the right is filled before the part on the left. So we have a problem of balancing of the mold. We won't be able to apply the same packing conditions on both cavities, and it may result in different shrinkages for the two parts. To fix this balancing problem, the software has a function called runner balancing, where you can set the min and max runner diameter you want and min and max gate diameter. Then you can start the runner balancing analysis, and the software will recalculate the runner and gate diameter to make sure that the two cavities will achieve their fitting at the same time. You can apply the same function for more than two cavities. As you can see on the screen, the two forefronts are identical. They're achieved at the same time. Many other results are available, such as fitting pressure, estimation of cooling time, sink marks, ease of fill, shear stress, shear heating, and much more. Thank you very much for your attention.